The routing protocol OSPF supports or has got 4 different type of stub network types. 4 different stub network types. The first one is simply the stub. The second one is called as totally stub. The third one is called as not so stub area. This is another type of stub area, but it is not so stub. Stub only, but not so stub. The fourth one is totally not so stub area. Among these 4, the first and the third one is RFC standard. Only on Cisco device you will see all 4, because RFC standard is what everyone follows. Cisco has got already always some extra. So the second one and the fourth one that you got totally, the word totally, this is Cisco's idea. When we say area as a stub area in OSPF, it will deny type 4 and 5 LSAs coming in. If you configure an area as a stub area, type 4 and type 5 LSAs are not allowed to enter. Next, totally stub. This will deny type 3, 4 and 5 LSAs. But again, as I told you earlier, this is Cisco's idea. Denying type 3. Denying type 4 and 5 is RFC. Along with type 4 and 5, denying type 3 is Cisco's idea. Now, what it means, denying type 4 and 5. Denying type 4 and 5 means the external redistributed networks and the router which is responsible for bringing the redistributed network inside OSPF, that ID which you called as type 4, they are denied. So no information about the external, no information about ASBR and the ASBR learned routes were allowed inside this area. When you configure an area as a stub area, not only the external networks come in, even the reason for the external routes coming in is not allowed. Who is the reason for external routes coming in? The ASBR. There is no mention of ASBR, which is type 4, and there is no routes of external network, which is type 5. But still you will be able to reach the external network because the ABR of the stub area the ABR of the stub area will be advertising a default route on behalf of the external networks. So there will be a default route generated as type 3 LSA on this ABR router, and the ABR router will advertise it to every router inside this stub area. So using the default route given by the ABR of the stub area, all the internal routers of that area will be able to reach the external network. Ask me question. If you didn't understand any part of what I said now about the first type, ask me question. Which means you already understood what is type 4 and 5. So now you understood what is denying type 4 and type 5 means. Am I audible? Thank you. Because it was long silent, no? I thought, fine. I'm not hearing them. All right, I hear you now. Fine, thank you. And next one is totally stop. You see, for an area to go to other area as well as to go to external network destination, the only path is via ABR, correct? For an area to go to external networks, which is in some other area, also to go to other area, the only hope, the only exit is via ABR. So when you configure an area as a stub area, the default route given by ABR will be used. Likewise, when you configure an area as a totally stub, even type 3 is denied coming in, which was the reason behind learning other area routes. Now, because they are denied now, we will use the same default route that is given by stub in order to reach the other area networks. When you can reach the external network via the default route, you can also reach other area routes, other area networks via the same default route, right? See, ABR will not be, sorry, area 0 will not be a stub for any reason. It cannot be a stub. So area 0 knows about every destination's location. So for an area to go to other area or to go to external network, they have to touch area 0 via ABR. So instead of learning all other area routes in my area, I'll simply have a default route to my area 0 via ABR. And ABR, which is connected to area 0, will provide the exact path to reach those destinations, because my ABR is also a part of backbone. You no need to learn the other area routes nor the external network routes in every single router. We'll simply learn only a default route pointing towards the ABR. And because ABR is a member of area 0, ABR can take you to anywhere which is more than sufficient for someone to reach other area networks as well as external network. Why unnecessarily we learn other area routes in the routing table, take time to process, consume the buffer? Why? It's waste of process, time taken, space consumed, the resource utilization, update, bandwidth consumption. All this can be minimized by making an area stub area. Question please, the first two if you have. Yeah, wonderful. We will also have a nice demo. I'll try to bring our own topology, the one which we used to have earlier, and I'll explain you. So let's take this topology. Now I will cut this portion. If you see here, we got area 1000, area 500, and we got area 0. When I configure area 1000 as a stub area, what really happens is no 4 and 5 allowed, meaning this router, let's say the router ID is 8.8.8.8. This router ID is carried by this router. It comes to router 5 as type 4 LSA. Type 4 LSA is the LSA that brings the router ID of ASBR. The router ID of ASBR that is originated from R1 comes to R6. R6 will give to R5. R5 will say, I'll not give it to 4. Why? Because R5 area 1000. R5 is also a member of area 0, but R5's area 1000 is a stub area. So R5 will say, I will simply give you a default route. I cannot advertise this type 4 LSA. Also, the type 5 LSA which originates from router 8, when it comes to router 5, router 5 will not give it to 4. Same reason, because router 5's area 1000 is stub. Router 4 is also configured as a stub. Router 3 is also configured as a stub, meaning every router inside this area 1000 must be configured as a stub. Not simply area 5, not simply on R5 you will configure stub. Not simply R5 area 1000 side you will configure as a stub. You need to configure every single router in this area as a stub area. If you fail to configure R4 as a stub, then there won't be neighborship coming up in between 4 and 5 and 4 and 3. The neighborship won't come up. The hello packets will carry even the stub bits. That bits which is turned on in the hello packet coming from R5 will be checked against the R4's stub bit. If the match don't happen, they don't accept, agree, allow as neighbor. So in order to have neighbor, the area ID must match, the timer should match, even the stub should match. Stub type should match. Okay, now what I'm coming to say here is the entire area 1000 should be every router, each and every router in this area, you should go inside and say you are a stub. So when you configure this router as a stub router, they are going to go down and come up again. The neighborship, if it is already there, neighbor, it will go down because the policy changed. It will go down. It's a disruptive one, okay? Stub configuration is disruptive one. The neighbor will go down and re-establish the neighbor by checking the stub bits. If stub bits are matching, only then the neighborship will come up. So type 4 and type 5, they are not coming in. A general reminder, type 4 is originated from R1. Type 5 is originated from R8. Type 5 will be simply forwarded by every router, whereas type 4 gets regenerated on every ABR. Type 4 generates from R1 and it will again regenerate from R5 if it needs to go to R4. But because R4 and R5's area 1000 side is a stub, it won't regenerate. Type 4 won't be regenerated in R5. Instead, a default route will be generated and advertised to R4, and R4 will advertise to R3. So R3 and R4, instead of learning these networks, instead of learning these external network coming from BGP, they will have only a default route. Using default route, they go up to here, and router 5 knows, router 5, because it's a part of area 0, it has got clear route to reach here. So only that area routers won't have precise route. If you check the routing table, show IP route 1.1.1.1, it will say no route found. But if you ping, it will ping because you got a default route. And that default route originates from R5. I cannot configure area 500 as a stub area because it has got a ASBR. See, if you have an area with virtual link, you cannot configure a stub area. If you have a ASBR, you cannot configure that area as a stub area. But let us assume we got something like this. What? Area 1000 has got a ASBR. Hey, wait, before that, let me finish the second type. So I have just covered stub. So stub will deny 4 and 5 going inside. When I configure that area as a totally stub, 3 is also getting included. See, whether it is other area or other autonomous system, the only hope for all these routers is to go out this way. So instead of learning all these area routes, we'll make use of the same default route. So The routing table of R5, sorry, the routing table of R4 and R3 will have only root information of local area networks. Because type 3 is denied, no? If type 3 is denied, area 500, area 0, advertised routes will not be, cannot learn because no one is giving. Type 3 is denied. So 4 and 3 cannot learn those 10.56 network, 10.16 network, 10.18 network, 8.8.1.1, 8.8.2.1, 8.8.16.1. Those networks cannot be learned because they're coming from other areas. Type 3 is denied. But still you will be able to ping both 8.8.8.8 as well as 1.1.1.1 by using the default route given by R5. So far good, is it clear? Thank you, Rashidhar. Now let's move on to the third type. Third type is called as not so stub area, NSSA, not so stub area. For that, I want to change this topology. You see, let us take this topology. What is the difference between this topology and the previous one? In this topology, you got an ABR in area 1000. You want area 1000 to be a stub area, but you got a ASBR. We saw, like, if you have a ASBR, that area cannot be a stub area. We saw if you have a ASBR, that area cannot be a stub area. That's why we are saying not so stub area. You see, I want, but I don't want. Something like that. It's a stub area, but not so stub area. What will not so stub area do? If I configure area 1000 as not so stub area, what all will happen? Listen carefully. This is the only type many people don't know, don't have much clarity. When I configure, so one thing I have explained to you so far about NSSA is, NSSA is used in a situation where you have ASBR in your area. You got ASBR in your area in which you want to configure stub. Is that background explained very well? Did you understand when, in which circumstances the NSSA is needed? NSSA is needed only when you have one ASBR in the area which you want to be a stub. Is that very well understood? All right, thanks. I say that again. You're the only best student in the class for me. Sometimes I need that acknowledgement, otherwise I cannot proceed further. Fine, thanks for the acknowledgement. So we understood one thing, that we need ASBR in an area. We got it here. So NSSA will not suit anywhere else, okay? You need to have ASBR. Now, let us understand what this NSSA will do. When we configure NSSA in this area, you will simply go to this router and say router OSPF1 area 1000 is NSSA. The same command you will also say in this router, also in this router. Router OSPF1 area 1000 NSSA. You'll put this command on every router. You must put it on every router, not only on ABR. Now what will happen is router 3 will say, okay, this area 1000 is a stub only, but again, not so stub, slightly stub, not so stub. To present it in OSPF language, all this external network, which used to originate as type 5 earlier, yes or no? The external network originates from ASBR and it originates as what? Type 5. Now, because you configured router 3 as not so stub area, router 3 says, no, type 5. No, type 5. But I have a option. I cannot accept type 5 because stub, the third character, the third letter is stub. Yes. I cannot accept type 5, but I'll accept what? As type 7. So instead of me taking those rip routes as type 5, rip protocol. Instead of me taking those rip routes as type 5, I take it in as type 7. Because type 5 I should not allow. So I'll accept it as type 7. Like most of the Indian government officials. No, we will not take bribe. No, we are a friend of public. We will not take bribe. But we will steal. We will cheat. We will put laws in such a way they will come and give you gifts. We no need to ask. We will not ask. We will make them give. That is how we set the laws in the country. They'll come and give voluntarily. Stub, but not so stub. So still everything is happening as usual. Instead of type 5, you bring those external networks as type 7. Okay. Why you need this? Let it be type 5 only then. Why should I accept this as type 7? What is the advantage of me receiving it as type 7? The advantage is you are denying type 5 as a result. This type 5 that is coming from router 8 is denied. That's it. Your aim in making area 1000 as a not so stub area is you want to use the local ASBR instead of ASBR that is there in area 500. You do not want to send any traffic to BGP's network. Say BGP, via BGP also you learn 11111, 1.1.16.1. Here also you learn the same network because it's an internet. You got two internet connection. For your understanding, I am saying RIP and BGP. You can also take ISP1 and ISP2. ISP1 is locally connected to R3 in that area 1000, whereas ISP2 is connected to area 500. Sometimes the metric of this RIP route may be very high compared to the metric coming from BGP. So all your router will try to take the path whose metric is only 10. Router 4 and 3 and 5 tries to take a long route instead of taking this local exit. It is trying to take a long route, meaning it is consuming all your area 0 resource, area 500 resource, and then it goes out, which you do not like. So what you did is you simply made that area 1000 as not so stub area, so that type 5 will be denied coming in. R4 now have a precise route to those one network 1.1.5.1, 1.1.12.1 pointing towards R3. So they go this way only. So what you can do is optionally, see this is not by default, optionally, you can go to R5 and write a static default route, repeating again. I'm teaching you not so stubby area. In not so stub area, no default route is injected by R5. No default route is injected. R5 will not give you any default route to R3 or R4. So you write a static default route in R5 and go under router OSPF. No, write a static default route in R5 pointing towards R6 and use the command default information originate under OSPF. Under OSPF you use default information originate command. So that R5 will also advertise a default route. R5 will advertise a default route. Why do we need this? In case if this ISP1 connection fails, R4 will start moving this direction. R3, R4 will start moving this direction to reach the internet via ISP2. That's the idea. As a backup path, you can use ISP2, for which you need to write a static default route pointing towards R6 and use the command default information originate under router OSPF in R5. Is that clear? Not so stub area, is it clear? And this is, thank you. This is as per the RFC standard. Not so stub area is as per the RFC. Yes, please.
So for the NSSA, if there is no default route that we are sending from the APR, then the only way out for the
Correct. The only way is ISP1, and if ISP1 fails to provide a route, or if ISP1 connection drops, connection to ISP1 drops, then R4, R3 cannot reach external internet.
does it have
Yes, see, not so stub area will not deny, not so stub area will not deny type 3. Not so stub area will deny only 3 and 5. Sorry, not so stub area will only deny 4 and 5. So to other areas, you will have to the other areas you will have a precise, detailed route given by R5. Not so stub area. Sorry. Yeah. Usually the ASBR will generate the external network as type 5. But because R3, the ASBR itself, R3 itself is a ASBR, because we have configured it as NSSA, R3 says I cannot generate type 5 now, but I can advertise these ISP1's network RIP routes as type 7 because I'm not supposed to generate type 5. So it generates as type 7 instead of type 5. The last piece is totally not so stub area. Please understand, when I make this as totally not so stub area, earlier I told you type 3 will be coming in. Only 4 and 5 is denied. Yes or no? Now, when I say totally not so stub area, type 3 also denied. Instead, repeating again, instead, a dynamic default route will be given by the ABR to all the inside routers. So in the not so stub area, the default route was not coming by not given by R5. So we write a default route pointing towards R6. We also use the command default information originate so that the default route will be injected. We do manually those things. We make R5 to inject default route by writing the static default route pointing towards R6 and by saying default information originate always, which is a additional work we did. But when I make an areas totally not so stub area, type 3 is going to be denied by NSSA, means ABR of that NSSA area. That same ABR will inject dynamically generated default route to every routers inside this totally not so stub area. In our case, it is area 1000. All other rules are same. Repeating, all other rules are same. Meaning, I will, if you take the routing table of R4, to make you understand clear, I'm telling you this. If you look into the routing table of R4, you will see every routes to the external with clarity. A detailed route coming from ISP1. You'll have a detailed route No default route, detailed route, because type 7 is allowed. And then you will have a default route as IA. These are all N. N means not so stub area, type 7. Instead of E, it will be N, November. And there will be a IA default route pointing towards R5. There is no IA with precise route, meaning you will not have other area routes because type 3 is denied. The only type 3 that comes in is the default route, type 3, the default route. So R4 will have a detailed route for all the external networks as N, and it will also have detailed routes for the local network. Local network in the sense those networks that are inside area 1000, and it will have a default route to go to area 0, area 500, and also to ISP2. And this default route is given dynamically, generated dynamically, given by ABRR5. So I have given you a very clear difference and use cases of all this 5 and not so sorry 5 stub area, sorry 4 stub area. I also want you to go through this video one more time. Come with clear knowledge of all this 4 difference between these 4, so that when I do the lab you will enjoy. You will not get stuck in the middle. Any question you may ask now.